of you or not? Yes, Chili. Hi, Amir. Yes, definitely. I was also waiting for these marathons. So, guys, today is you can say your countdown starts now. So, we are coming with these marathon sessions for better revisions. Yes, Sagrika. Good morning, Jyoti Prakash. Good morning. Please tell me, am I properly audible and visible to all of you or not? So guys, in this session, we are going to revise the complete casting within 2 to 2.5 hours. So guys, today's topic is metal casting. And I feel everybody knows this is the part of your production technology. Okay. And guys, if I'm talking about the weightage of this topic, 2 to 3 marks is the weightage of this topic. So only with today's session, you are going to confirm your 2 to 3 marks. Yes, Shruth, good morning. So without wasting the time, guys, we are starting the session now. Okay. So guys, this is some detail about me. Those who are watching me for the first time, my name is Dheeraj Sardana, 10 plus years of experience, and today's topic is related to the production technology. Shruth, yes, good morning. Shashank, good morning, dear. So guys, before we start the session, there is some information related to the scholarship test. You can get up to 90% of the scholarship for GATE and ESE preparation programs for 2024. And guys, 24th December would be the date of this test at 8 p.m. You can register in the description box for the same. Definitely, I mean, you will be getting this within 1 to 2 days. Okay. So like today, I am starting topic wise marathon ending. Good morning. So Maha Marathon series would be starting from 3rd of January. Okay, there we would be having one subject one day, and it would be for all the branches. Sorry, it would be for all the subjects. Okay, and every day we would be going with one subject in that case. Okay, so you can say this is today we are talking about casting. In that series, you would be having one day for one day for Tom, one day for machine design. Like that, the sessions would be going on. Naveen, hi dear. So guys, if you are preparing for GATE, you want free ebook to download, or you want to appear for some workshop for GATE preparation program, or you want to appear for the scholarship test for GATE and ESE preparation at BYJU'S. So for that, my dear, the link is there in the description box. You can register there for all of the following. Okay. I mean, obviously, full day marathons would be there. So they would be starting in the morning and they will go till 7 to 8 hours. Okay. So morning to evening, the sessions would be. Chandra Buleshu, good morning, dear. So without wasting the time, let us start the topic, guys. So first of all, I would be making a disclaimer here that this casting process, which I teach in the normal classes for around more than 15 to 18 hours, that we are going to complete here only in 2 hours. So definitely here this is a quick revision type of series. Okay. So we would be going for only the necessary things, means we will be revising completely. But maybe every derivation we are not going into because we are preparing for the GATE. So it would be a good revision for all of you. Okay. This is a revision kind of thing. So yes, let us move forward. So guys, when we are talking about the metal casting, how we will be defining it? So my dear, metal casting is said to be the mother manufacturing process, in which generally what we do, the product is made by solidification of the molten metal, and that molten metal is filled into some predefined cavity. Like if I want to make a product of some specific shape and size, for that what I will be doing, I will be making a cavity of that shape and size. And after making a cavity, I would be pouring molten metal into that. Then molten metal will solidify and I will get the same shape and size of product. This is how the casting is defined. Shubham, good morning, dear. So this is how the casting is defined. So it is defined as the product would be made by, it is a mother manufacturing process of making the product by solidification of molten metal in a predefined cavity. This is how we would be defining the casting. So maybe some of you have not studied in the classes. So for them, I am also giving you one look how you have seen this process in the manufacturing labs. Okay. If I tell you, let us say you want to make a product of this shape. You want to make a product of this shape. This is the product you want to make. Okay. So if you want to make this product, first of all, I would be quickly telling you how in the laboratory the products are being made. Yes, thanks Chili. So guys, just like and share the session so that other student can also join here. So guys, let us say you want to make this shape and size of product. Okay, this is the final product you want. So for that, first of all, I would be making a pattern. What is pattern? Pattern is defined as the replica of the final casting product. Matlab, it would be very much similar to the final product. Okay, so I would be first of all making a pattern. Then I would be having some molding flask. How the molding flask looks like? This type of molding flask I would be having. They would be open from top and floor. They would be only 4 molds, and top and floor would not be there with them. So guys, we would be having such type of molding flask. So guys, first of all, we would be taking a wooden board. This is the wooden board, and on this wooden board, I am putting this pattern. This is my pattern. I am putting this pattern like this. Okay, and this pattern would be there in the molding flask. So I am also making the molding flask, and you already know molding flask is only the 4 molds. So molding flask will look like this. So this is the molding flask. Okay, this is the molding flask. So my dear, now this is the pattern. Okay, we have kept it, and this is the molding flask. As it is open from top and bottom, so my dear, we can put anything inside. So my dear, along with the pattern, now what we are going to do? Along with the pattern, we would be keeping first of all 2 ingates. Okay, here and here you would be putting some ingates, and on the ingate is just a metallic piece. Then you would be having a cylindrical thing which is said to be sprue. Then you would be putting a cylindrical riser here, and after putting all this, you would be filling up some sand. Yes. Thanks dear, thanks Amin for that. And guys, now I would be putting some molding sand inside. I would be keeping some molding sand inside. So what is molding sand? You can say this is right now a silica sand. We will see in detail what it is. So we would be putting some sand inside. Okay, after putting the sand inside, we would be making that closer. To increase the density of sand, we would be taking a wooden hammer, and we would be hammering it to make it perfect. Okay. After that, my dear, what we are going to do, you can feel it from here. Like let us say we want to make this product. This is the pattern, and let us say this pattern is of 2 parts. Okay, I am making it more clear to you. So let us say this is a product which is of bigger size. The pattern will be in 2 parts. So one part of the pattern we have kept this. Now, my dear, we would be having another part of the pattern on one more molding flask. Okay. So for that, what we are going to do, I am telling you that as well. Okay. For that, what we are going to do, I am telling you that as well. You would be having once again the same wooden board. This molding flask will be taken away, and we would be putting one more molding flask. And in this molding flask, we are going to have the second part of the pattern. Okay. Now the second part of pattern would be utilized. This is the second part of the pattern. Okay. And my dear, here also you would be putting some ingates. And after that, you would be filling it with the sand like previously you have done it. Okay. Yes. Sagrika, thanks for that. So guys, I would be filling once again the molding sand, and I would be giving some kind of hammering once again. Umar, good morning. So after hammering once again, this would be tightened. Okay, I would be hammering it. And after that, my dear, what we are going to do? We are going to remove these pattern part, because here we need to make the cavity. So we would be removing these parts which I am making hatch. Here also these parts are removed which we are going to hatch. So after that, you would be just joining these two, and this molding flask and this molding flask we are going to join. And when we are going to join, we would be having a complete box. So 2 molding flasks are joined with each other now. Okay. And the line which would be separating them is said to be the parting line. Now you know, my dear, here you will be having some kind of cavity of this shape. This shape of cavity we are having it in like this. Okay, this type of cavity we are actually having here like this. And other than this cavity space, we would be having the sand all around. All around sand is there. Silica sand is there. Silica sand. Guys, we are starting the process Okay, so this is just an introduction I am giving right now. So, Midun, good morning, dear. So, guys, now what we are going to do now, we are going to pour the molten metal. Now we are going to pour the molten metal here. And when we will be pouring the molten metal, as it is cavity, it will start filling. And when this would be filled like this with the molten metal, you know, after that it would be solidified. And after it solidified, we will be breaking the mold. And after breaking the mold, you would be separating your product, and finally you would be getting this kind of product what you are making of. So this, in a rough way, I have told you. Bisheti, hello dear. So this is as a rough process I have told you what you have seen in the labs. I have skipped some subject, not some subject. I have skipped some steps, okay, which I have not shown here. But in the laboratory, this is the basic thing you have seen. This I have just told you to revise once again that what actually the casting is. Now, my dear, this entire process we are going to see technically that what are the things we are going to do. This is just a rough way I have started. Now, your syllabus point of view things are going to start. So in general, this kind of casting process is having around 10 steps. Okay. First step is process. First of all, you need to make the pattern, because you know, to make the product, you need to make the cavity. To make the cavity, we need a pattern. So very first step is to prepare the pattern. Once the pattern is prepared, after that you would be preparing the mold. What was the mold? This entire thing was the mold. So my dear, after the preparation of pattern, you would be going for the mold. Once you are going to make the mold, then you would be going for the gating system. Then you would be going for the riser. Gating system and riser. Gating system is something from where molten metal is entering, and riser, you have seen, it is going to tell you whether the casting is filled or not. So my dear, these two steps are very important, and from here numericals are coming in the gate examination. So guys, that's why they are very important. So my voice is clear or not? Biseti, Midun, please tell me. If there is an issue, please tell me, guys. And do like and share the session. This session we are coming up on your request only. It's clear. Umar, just refresh it. Umar, just refresh it. Okay. Very good, Manas. So just like and share the session, guys. We are just starting this, and within 2 hours I will be completing it. Okay. Sure, Biseti. Actually, this weekend we have just started it. I have already planned 2 things for you. Not only the questions, you will get the short notes of casting, or you can say formula notes of casting also tonight. Tonight you will get the formula notes of casting. Okay. So definitely we would be having practice session, but not today. From Monday onward, we will continue that also. Okay. So that depends on your response. If you would like it, you would be continuously attending. We are going to continue all these things that already I have planned. Okay, guys. So my dear, next is melt the metal, because to pour the cavity where molten metal is poured, you need to melt it in the furnaces. Then we will be having pouring of molten metal, then solidification, then fettling means breaking of mold, then finishing and testing. Because once the casting is prepared, its surface is rough, you need to finish it, and then you will be testing whether the casting is fine or not, good or not, on all the criteria. So this is the total procedure which we are going to follow. Okay. So you have seen we have used 2 parts of pattern. So there were 2 molding flasks. So molding flask which is at the top is said to be cope, and that at bottom is said to be drag. If sometimes the pattern is of bigger size and we need more than 2 molding flasks, then top part is cope, bottom is drag, and in between part is said to be cheek. So then in that case we would be having 3 parts of the molding flask. Very good, Abir. So guys, now we are starting. First of all, actually, what is step number 1? That is preparation of pattern. So to understand the preparation of pattern, we must know what is pattern actually. Generally, whenever I ask to the student that what is pattern, they say the pattern is same as that of final product. I would say no, it is not same. It is similar. Actually, pattern is the replica of the final product. So if I want to make this type of product, then you will see the pattern would be looking similar to that, not exactly same. So why I am saying similar? Because there would be some differentiation within size and shape. and those differentiations are said to be allowances. So whenever we are making the pattern, it is looking similar to the casting product, not same, because some sizes and shapes are going to be different, and that difference is very small. That is why we call it as allowance. So very first type of allowance is said to be the shrinkage allowance. So first of all, I would like to tell you why we need it, okay, and what it is. So let us see one by one. For that, I am showing you cooling curve. So my dear, cooling curve is nothing but the temperature time diagram. So in this curve, we are going to have temperature on the y-axis and time on the x-axis. So this type of curve is said to be temperature time diagram. So this is said to be the cooling diagram, cooling curve. So my dear, you know, whenever you are going to melt the metal, you would be having some piece of metal in the raw form at the room temperature. So you were having at room temperature piece of metal. Okay, it was in solid format. So you have kept this metal piece inside the furnace, and its temperature would be increasing because of heat, and it would be reaching to the melting point temperature. This is said to be the sensible heating. Then my dear, after that you would be melting it, because at melting point temperature it will melt and it would convert from solid to liquid. And after that I am not stopping it. Why I am not stopping it? Actually, I can pour, whenever it becomes liquid, I can pour it into the cavity. Yes. Yes, Umar, you can say that. Very good, Vineet. So here, whatever heating is going on is said to be the latent heat. Okay, latent heating. So if I want, I can pour this molten metal into the cavity. But my dear, in general, furnace and cavity are at a distance apart. Like maybe furnace is, let us say 500 meters away, or maybe let us say 10 meters away. So when molten metal will be coming from furnace to cavity, in that time it would be obviously having contact with the surroundings. So there it would be losing some amount of heat. Okay, it would be losing some amount of heat. So if in that case, if I would be taking that molten metal from here only, then maybe after reaching to cavity, it would have some solid amount, because some heat would be lost. So I cannot take risk, otherwise my casting would be defective. So I will continue heating it, and I will be heating it to above 100 to 150 degrees Celsius. Okay. Melting point से 100 से 150 डिग्री सेल्सियस ज्यादा we would be heating them, and that extra heating is said to be the degree of superheat. That extra heating is said to be the degree of superheat. So my dear, at this temperature we would be taking this molten metal and pour it into the cavity. So this temperature is said to be pouring temperature. Now my dear, what is going to happen in this universe? Any material, when you are talking about, they have two things. One is they heat. Whenever you are going to heat them, they are going to expand in size. Whenever you are going to cool them, they will contract in size. So heating will result into expansion, cooling will result into contraction. So if you would be having some metal piece from room temperature to melting point temperature, it would have been expanded. From this to this, it would have been expanded. From this to this, it would have been expanded. So the size of that molten metal, whatever you have taken initially at room temperature, would be more. Now when you would be pouring this molten metal at this stage, then my dear, first of all, that molten metal would be reaching to the melting point temperature. Why? All the time it is in contact with the surroundings, so obviously heat loss is going to take place. Definitely we need, but वो हम defect में बात करेंगे, ठीक है? So my dear, when it is going to be cooled from this pouring temperature to melting point temperature because of the surroundings contact, then my dear, obviously some heat would be lost. Cooling is going to happen. Then my dear, whatever the size molten metal was having, it is definitely going to shrink. Okay, but when it would be shrinking, if you see in our diagram, when it would be shrinking, then my dear, if this was our initial size of the molten metal in the cavity, then my dear, you also know one thing, that due to the temperature reduce, it would be getting shrink to this size. We need not to worry, because this riser will be giving the molten metal, and once again the cavity will take the same shape. So my dear, this contraction will be taken care by the riser. After that, my dear, it would be converting to the solid once again. Then also some shrinkage will happen. That shrinkage is also compensated by the riser. But my dear, at this stage, the entire molten metal is converting into the solid. So because of that, now riser cannot help us. Okay. So after that, my dear, when it would be going to the room temperature, for this part of cooling, whatever the shrinkage would have taken place, that would not be fulfilled by the riser. So for this part of shrinkage, we need to give some allowance. Why we need to give allowance? Because my dear, whatever if you are having the pattern of this size, okay, you have filled the cavity to this size. But my dear, due to the shrinkage of the third stage, the exact size of product would be lesser than this, because in the last stage, whatever the shrinkage would happen, that would not be compensated by the riser. So the point is, if you are going to make pattern of yellow size, you would be getting the product of blue size. And if you want the casting product to be of yellow size, then my dear, you need to make the pattern slightly bigger. So then you have to make the pattern of white size. So if you would be making white pattern, you would be getting yellow product. Okay? If you would be making white pattern, you will get yellow product. If you would be making yellow pattern, you will get the blue product. That is the point. And that is Pulaki Deepak. Yes, very good Deepak. बहुत ही बढ़िया, शानदार. So this is said to be the shrinkage allowance, guys. So my dear, now you have seen that why this shrinkage allowance is required. Now I would tell you one more thing. Whenever these shrinkage allowances are provided, they are provided on the linear dimensions. Okay? Like let us say if I am saying that, that I want a product of this size. Let us say this is the size. I am saying this to be 200, this to be 150 and this to be 100. And let us say it is given that shrinkage allowance is 1 mm per 100 mm. That would be a property of material. How much it shrinks. So for that, I would be making a component of which size? I would be making a component of which size? I would be making a pattern of 202 into 151.5 into 101. Because after shrinkage, it would be getting this. So this is how the shrinkage allowances are provided, my dear. So just like and share the components. I was expecting more students to come in this session because it was kept on your request only. So guys, now we are moving further. We have already seen what is the meaning of shrinkage allowance. Okay. So that we have already explained. The first two stages is compensated by the riser. Third stage was not compensated by the riser. Okay. So my dear, if you are talking about first stage, it is said to be liquid shrinkage. Second stage is solidification shrinkage. Third stage is said to be solid shrinkage. Nailani beneath, it would be given to you. For that, this table is there. If you see this table, this is telling you about the shrinkage allowances. For bismuth, it is negligible. For white metal, it is 5 mm per meter. It is 9 to 10 mm per meter for cast iron. For copper, 11, aluminium, 13, steel, 20 to 35, brass, 23, zinc, 24. But you need not to remember it. This would be given in the exam. So you need not to be worried about this, guys. Okay, this would be given to you in the exam. That what is the shrinkage allowance in mm per meter. So that would be given to you. Very good, Shreyas. बहुत ही बढ़िया. So that would be given. So no need to worry about that. Okay, guys. So when we are talking about this, there is an exception related to cast iron. So when we are talking about the cast iron, so for cast iron, many where things are given in the wrong way, but I would like to correct it. Some people are saying in cast iron, shrinkage allowance are given in opposite direction. That is not correct. Shrinkage allowance is given in the same direction for every material. Cast iron is not exception in that way. But the problem is, in case of cast iron, in the first stage, shrinkage happens. So that shrinkage happens. And in the second stage, expansion happens. So that is the expansion, that is the, you can say, exception of the cast iron. That is the solidification shrinkage. It gets expanded but not shrink. So that expansion and that shrinkage is going to compensate for each other. So that is why for grey cast iron, we need not to have any kind of riser, because riser work is done by these two. But shrinkage allowance was provided for the third stage. So in third stage, it shows the normal behavior. That is why even if cast iron comes, it would be in the same way. It would be sold in the same way. The exceptional part of cast iron is Here we need not to provide any riser. All other things will remain the same. Is it clear for everyone? This is a question of doubt for everyone. I was teaching this from 2015 on YouTube. People are saying, sir, but everybody saying cast iron have different behavior. So guys, GATE have asked 2 times this question. Every time they have taken grey cast iron similar to the other materials. You can see 2008, 2016 question. Both the times they have asked this question. Okay. Yes, dear, very good. That you remember. Very good, Shubha. So you can see here liquid and solidification shrinkage are maximum for aluminium. Total is maximum for steel. Grey cast iron I already told you. Moving to the second allowance. This is the revision. I would be going faster. Second allowance is draft or taper allowance. So my dear, if you are going to make your product or pattern like this, okay, then what will happen when you will be taking the pattern out from the mold? Then my dear, it would be showing some mold wall would be showing some resistance from the walls. Because of that friction will happen, and because of that friction, some erosion of molding sand can happen, and some part of sand may come into the cavity, and they may make the product worse. So to avoid this kind of thing, we would be always making the pattern at some angle. So we would be providing a draft of 1/2 to 2 degree. So this draft is provided from half to 2 degree. And by doing that, what is going to happen? Now, my dear, if we have this type of cavity, okay. So once this pattern would be coming out even by some amount, the contact of entire pattern would be not there with the walls. That is the benefit. So there is no erosion will happen in this case. So that is why we are going to provide this draft allowance. I feel everybody understood. Any doubt if you have, you can ask. We are moving to the third type of allowance, that is machining allowance. So whenever you are going to make a casting product, its surface is found to be rough. Okay. I feel Shubham, you have remembered all the things. Okay. So now we are talking about the machining allowance. So when we have a pattern, when you have made the product, that product surface is not very good. Surface is going to be rough. So my dear, to make this surface finish, we are going to provide machining. You cannot use that product simply after the casting. So when you will see the surface after the casting, you may be feeling you are going to get this type of surface, but in reality the surfaces are having a lot of roughnesses. So my dear, with that surface roughness, you may not be able to use the component. So we are going for the machining of the component, where we are going to machine it and we will be producing some better surface finish. So because of that, some material will be removed. So because of that, we need to make the pattern size slightly bigger than the kind of product we are looking for. So this type of allowance is said to be machining allowance. Then we are going to have distortion allowance or camber allowance. So if you want to make some such kind of difficult intricate shapes, machining means we are going to machine it. Machine means removing the material. Machining means we are going to remove the extra material. Okay. So when you would be going for lathe operation, that machining will happen, material will get removed. It is a negative, you can say, process. Like when we are talking about casting, here we are making it, there we are cutting it. Okay. So when we are talking about distortion or camber allowance, if you are going to make with some such intricate shapes like U shapes. So my dear, here this length is L1, this length is L2. You know that change of length is given as L alpha delta T. Okay. So if length is more, delta L will be more. So delta L for this side and delta L for this side is going to be different. So because of that, after solidification, it would bend like this. But we want straight product. So in that case, what we do, we are going to bend it in the opposite direction. So that after this solidification, after this, it would be becoming of the same shape as we are requiring. This type of allowance is said to be distortion allowance. How much we need to do this? That would be definitely known by the person who is doing it for 10-15 years. So it would be hardly the matter of experience. Okay. We are moving to the last type of allowance, that is shaping and wrapping or shake allowance. So this is the last type of allowance, I feel so. So when we are talking about this allowance, whenever we are going to remove the pattern, the way to remove is, first of all, we are going to hammer it. So after, when you will be hammering it, why we are hammering it? So that the molding sand which is stick to the pattern, it will go away from the pattern, because we don't want to, you can say, distort the shape of the cavity. So when you would be hammering it, sand will go sideways. So because of that, the size of cavity will increase. Okay, so when you will be removing the pattern, the size of cavity is increased by this amount. So because of that, we need to keep the pattern size slightly smaller. This is the only allowance which is a negative allowance. All other allowances are increasing the size of pattern, but this allowance is decreasing the size of pattern. Okay, so this is said to be all the types of allowances to be over. Now we are moving to the material of the pattern, and with that we would be completing the first step. Then we will move to the preparation of mold. So my dear, when we are talking about the pattern material, the very first material we are going to use is the wood. So my dear, the best part about wood is it is easily machinable. It is easily machinable. Wood is easily machinable and it is light in weight. So that is why this is the most preferable material for making the pattern. But it has some negatives also. What are the negatives of wood? It is going to get swell whenever water is getting absorbed. So definitely if it would become swell, its size and shape will change. So we never want this thing to happen. So because of that, we were in search of some better material. Second, we reach for metal. Metal is definitely not going to swell on keeping the water content. Very good, Utkarsh. So, but there are some other problems with metal. Metal is going to corrode. So that is the problem with metal, and metal is heavy in weight. So because of that, we wanted some better material. We reached to the plastic. So plastic have light in weight, easily machinable, everything is good, but only thermal instability. When you are going to heat the plastic, it will show change of size and shape. So because of that, we were searching the other material. This is wax. Wax is giving you extremely better surface finishes used for investment casting. Okay. Then we went for the rubber. Rubber is also very light in weight. Everything is good with rubber. But the problem is elasticity. That if you have a pattern of rubber, maybe due to the weight of the sand, it may get compressed. And if it would be getting compressed, the size of cavity will get reduced. It may get compressed like this. And after removal, it will again come back to original shape and size. So elastic deformation may result into bulging phenomena. So to avoid this, we can make rubber pattern only for small and medium size of castings. For large size of casting, we cannot use it. So guys, whenever we are using the wood pattern, okay, then with the wood are generally used for the master patterns. Okay, so master pattern are generally made for the wood. So whenever we are going to make pattern of metal, okay, then pattern of metal are made by wood. They are the patterns. So when they are made, you are going to provide shrinkage allowance for the first time. Then if you are going to make the final product of whatever the material you are making of, second time shrinkage allowance is provided. So if you are using the master pattern of wood, shrinkage allowances are provided 2 times. Okay, so that is the most important point from this slide. I would also like to say aluminium is also used for the casting process as a pattern. It is light in weight, and definitely there is a problem of making oxide. So everywhere some good and some bad, some pros and some cons are there. Okay, so guys, just like and share the session. We are still at the second step of casting out of 10. Okay, second step is this time the mold preparation. This is the preparation of mold. We are starting the second step, preparation of mold. Okay, more important are up to step number 4. After that, the things are very easy and less time taking. So when we are going to make the mold, we have already seen the process. We would be having a molding flask like this. Okay, so we would be having a molding flask like this. So after we will be having the molding flask which is open from top and bottom. Now we would be keeping our pattern inside like this. Okay. So when you are going to make the pattern like this, we are not directly going to put the other sands here. First of all, we are going to put some facing sand. Okay, we are going to put some facing sand on the pattern. Why this facing sand is going to put on the pattern? It is some carbonaceous material like charcoal, like coal powder, like wooden floor, lakdi ka burada. So those kind of material are kept onto the pattern. Why? So that whenever the molding sand would be coming, there should not be any kind of sticking between the pattern and that, so that we can easily remove that. Okay. And there is one more purpose that also I will tell you. Okay. So this is the facing sand. So facing sand we have seen. Now baking sand is nothing but the same molding sand which we are going to use to fill the entire mold. Okay, so to fill the entire mold, this is said to be the molding sand or baking sand. Okay, so that is making the back part of the pattern, and this is generally silica sand. Okay, this is generally silica sand, and it would be having Na2SiO3. Na2SiO3. Then, my dear, we are talking about the parting sand. When we have more than two molding flasks or pattern is in multiple parts, then, my dear, we are going to separate them also with a sand. Like this is coke, this is drag. To join them, before that we are going to put some sand. Before that we are going to put some sand. Okay, to avoid the sticking of both the mold. Okay, for that we are going. Yes, Chandra Buleshu, this is reusable. We are using the same in all the other casting. So this is a reusable kind of thing. But pasting sand, parting sand, they are not reusable. And mold wash is also not reusable. What is mold wash? After removal of pattern, we are going to use a paste. That paste is once again made up of some carbonaceous material like coal powder, sea coal, or wooden floor. That would be there with alcohol or water. Why we are making alcohol? So that वो नशे में रहे. नहीं, ऐसा नहीं है. Alcohol or water is used for making the paste. Okay. So paste is made and that paste is provided all around the cavity. Why we are providing all this? Because, my dear, whenever molten metal is going to enter in the cavity, at that time what happens? Some gases are going to get produced. So when those gases are going to get produced, okay, one thing is that gases are going to get produced. Okay. So, my dear, when those gases are going to get produced, so to remove that gases, we need to do one more thing. Okay. Why the gases are getting produced? When molten metal is coming, all these mold wash, facing sand, they are getting converted into gases actually. So when they are going to get gases, why it is required to make those gases? Because, my dear, if molten metal would be there in direct contact with the molding sand, molding wall, obviously you have just studied in the shrinkage allowance that molten metal is going to shrink in the 3 stages of shrinkages, 3 stages of solidification. So when it would be solidifying, my dear, then molding sand will create the resistance in that solidification. So if that would be creating the resistance, my dear, your casting would be having the cracks over the surface. To avoid that, we want some gap between the molten metal and the molding wall during solidification happening. So for that, we are providing this facing sand and mold wash, which gets converted into gas, provide a space between them. Okay. And that is why we are providing it, and this is said to be the property name as collapsibility. So I feel everybody got it. Utkarsh, permeability we are not talking about right now. Now I am telling you about that. Now those gases produced need to be taken out of the mold. Otherwise they will create empty spaces in the casting and maybe some defect will come like porosity and blowholes. So these gases needs to be taken out of the mold. So for that purpose, we are going to provide some holes. We would be having a pin like this. That is said to be the vent pin. So that vent pin is used to make the hole in the mold. So we would be providing some holes in the mold so that from that hole, those gases can go out. Okay. And also we will try to make this molding sand having some pores. That property is said to be permeability, to take that gases out of the mold. That we will discuss now. Okay, don't worry. So we have just seen all the things related to the molds. Now we are going to see the types of molding sand. So very good, guys. Very good, and बहुत ही बढ़िया. So guys, now we are talking about the first type of mold, that is green sand mold. In the green sand mold, we have 60 to 80% of silica sand, 20% of the clay, that is bonding agent, 6 to 8% water and 0 to 1% additive. Because of this water content only, the name of this is green sand mold. In GATE 2011, this question was asked that why green sand mold. In this, what is green indicates? Green indicates the moisture content. Okay. So this molding sand, when we are talking about, is weak because of water. So that is used for small casting. Okay, because its strength is very less. Okay. Then my dear, we are talking about the second, that is dry sand mold. If we take the green sand mold and take that green sand mold into the furnace for 8 to 48 hours, then the water content would be solidified. Oh, sorry, the water content would be vaporized. And when those water will be vaporizes, your molding sand would be having some pores, which will help the gases to go away. So that is improving the property of permeability in that. And my dear, when you are going to heat that from 150 to 350 degrees Celsius and 8 to 48 hours are required in the oven, the problem with that is it will increase the cycle time. Okay, Midun, are the composition important? Midun, compositions not very important for GATE. In ESE type of exam they are coming. But I feel you can remember for one, we have already discussed for one. I am not saying to remember it for 10. Only for one you can remember. Okay? Otherwise it is not coming in exam. Till now there is no question on it. Neither in ME nor in PI. Okay? So my dear, now we are talking about the strength of this is more because water is getting vaporized, and that is why the name dry is coming. So because of this problem, cycle time is more. Because of this, heating cost is more. So it is expensive as well as time taking, guys. Okay. So next we are moving to the third, loam sand mold. It is used only for grey cast iron. As you know, grey cast iron is something having different kind of behavior. It is not requiring any riser. So for this we are using, especially for loam sand mold, we have 50% silica sand and 50% silt clay is there. Okay, silt clay is there. Next is CO2 molding. So my dear, if you want to make your mold very hard, then you already know in your silica sand you are having Na2SiO3. We are going to react it with CO2. We will be passing CO2 from this mold. When you would be passing CO2 from this mold, it will get converted into Na2CO3. So Na2CO3 is found to be very hard material. So because of that, the hardness of the mold is getting increased. Okay, hardness of the mold is getting increased, and because of that, if you see the cases of core, when we are going to make the core, when we are requiring core, if you want hollow casting, if you want to make a hole in the casting, we need for cores. So cores are made by CO2 molding because cores are subjected to various hydrostatic forces. Like if this is the cavity we have, okay, so you would be having a core because you want a hollow casting. So core is made like this. Okay, so core would be like this, and molten metal would be applying some buoyancy forces, and because of that force there are chances of breakage of this core. So for that purpose we are making this of more strength and more hardness. For that purpose we are using CO2 molding process. Very good, Utkarsh. बहुत ही बढ़िया. So this is CO2 molding. Now we are coming to the properties of molding sand. Okay, the first property is said to be permeability. So as I already told you, whatever facing sand mold wash you are applying, that is going to get converted in the form of gas. Now to take that gas out from the mold must have some kind of pores, because from that pores that gas would be coming out very easily. So for that purpose, that property of taking out of gases in the lesser possible time is said to be permeability. This is a desirable property because if the gases would be there inside, they would be producing some defect in the castings. Okay, like porosity, like blowholes. Okay, very good, Utkarsh. That also we will talk at the later section when I will tell you the design of core. Okay. So my dear, whenever we see the permeability, this is found to be a function of the water content. It is found to be maximum at 8% of water content. Okay, permeability is found to be maximum at 8% of water content. I also explained you why it is so, but that why is not much required in this GATE paper, because that is required for interview part. Because in GATE nobody will ask you. Still, I told you whenever we are going to have less than 8% water content and more than 8% water content. In less than 8%, clay is not activating. Okay, and after 8%, water is so much that it is very difficult to evaporate all the water. So that is why the permeability reduces in other cases. Okay. Then I also told you there is something known as permeability number. There is a test performed because permeability is a desirable property. If permeability is lesser, casting would be defective. So for that there is a test performed. We are going to take a test specimen. Like we know some moulding sand is going to be made. So the same material we are going to make a cylindrical mould. And for that cylindrical mould, the diameter for a standard test is considered to be 5.08 centimeter. Height is also considered to be 5.08 centimeter. Okay, and there is a pressure difference between these two ends, and we are going to provide some volume of air. And when some volume of air is allowed to pass from this, we are going to note down the time which is taken by that air to pass through with this pressure difference. Then we define a permeability number as this is volume of gas into height of pattern divided by pressure difference into area into time. This is said to be permeability number, and if permeability number is more, permeability will be more. This is the first place where numerical will come. As this is a revision session, I am just going to revise the things. But as already requested by Amir and other students, as I already promised you also. So after every 2 topics, we will be having a practice session also. First of all, I want to know from you guys whether you are liking this session or not. Okay? Because if you want, I will definitely be coming for other topics as well. Okay? So if you want, you can say yes in the comment section, or you can definitely say me via Telegram also. If you want, we will be going for every topic. Okay, like that. So guys, here time is in minutes, area is in centimeter square, pressure difference is gram per centimeter square, volume is in centimeter cube. You need to use only these dimensions only. Otherwise, you will not be getting the right answer. Okay. Sure, Chandra Buleshu, we will go for every topic. Okay. So now let us see, we have already seen the permeability test. Second property is collapsibility. Collapsibility is already explained to you. I told you while the contraction, when molten metal is going to contract like that, then moulding wall will be creating some kind of resistance. To avoid this resistance, we were providing some gap, so that for that purpose some gas was coming, and that property is improved now. That is said to be collapsibility. Thanks Naveen for that. Abhishek sir, if we can get formula. Dear, definitely I already told you na. You may not be remembering. I have already told you after like today's session would be over. Tonight you will get formula sheet of casting. Okay. Then on Monday, if we are going for welding, then on Monday you will get formula sheet for welding. Tonight we have a session of vibrations. So you are going to get a formula sheet of vibration tonight only. Okay. After every chapter you are going to get. That would be a gift for you. So if you would be continuing the response, I will continue for all the subjects, and for all the subjects you will get the formula sheet for that. So now we are talking about the third property, flowability. So my dear, there are 2 properties where students get confused into. One is said to be fluidity, other is said to be flowability. So my dear, when we are talking about these 2 properties, fluidity is related to the molten metal. Okay. So the property of molten metal to flow is said to be fluidity. If molten metal will remain in the fluid state, it would be easy for that to flow. Yes, Abhishek, in Telegram channel only. Flowability is the property of moulding sand. You may be saying, sir, moulding sand is not liquid. And we have studied that only liquid and gas are generally flowable. So my dear, molding sand, whenever you are putting on the pattern, it needs to take the shape of the pattern. And for that purpose, we need to take a wooden hammer and we need to hammer it. And when we need to hammer it, for hammering process, when you are hammering wood, that molding sand must flow over the pattern. Then only it would be able to take the shape of it. So that property is said to be flowability. And to improve these property, we may be requiring some additives. Okay. Next property is refractiveness. You already know that that molding sand is going to be subjected to a very high temperature of molten metal. So my dear, to withstand that temperature and remain in the solid form, that property is said to be refractiveness. So it should be high for the molding sand. Okay. So actually this session is not for questions, but still for your information, I am having this one question. Otherwise, in this session, we will not do any question. Questions would be done in the separate session. This session is only for the revision of complete casting. So this is the gate question. You already know that riser is going to provide for the first two stages. So answer would be 7%. This is the famous question of gate asked 2 times. Okay, very good, Utkarsh, Shreyas, Shubham and Manas. Moving to the step number 3, we are talking about the gating system, my dear. Okay. So first of all, we must be aware of why the gating system is for. So you can see 50 minutes are passed and मुझे पता नहीं चला कब चले गए. Okay. So likewise, within 2.5 hours, if we are able to cover this, it is going to be a very good thing for us. Okay. So next we are talking about the gating system. So my dear, gating system is related to all okay, Shubham, don't worry, that I will separately send you. But as if you are talking about generally strength, generally we are only requiring the strength and permeability. So for permeability it is coming like that, and for strength it is coming like that. Strength is maximum for 4 to 6%. Permeability is maximum for 6 to 8%. Other graph you need not to remember. Okay, there are vast things if you are going for. Everything is not required. Okay. Yes, great. That is what is required. पता नहीं चलना चाहिए कब time pass हुआ. Okay, so now we are talking about the gating system. So my dear, gating system is subjected, or you can say meaning of all those elements which are related to the flow of molten metal from the ladle to the cavity. From ladle to cavity, all those elements which are responsible for the flow of molten metal, they are said to be the part of gating system. But the point is, what should be an ideal gating system? Means what should be the characteristic of a gating system? So my dear, gating system must have one possibility, that it must not provide any kind of outside impurity. It must have only that molten metal for which the casting is to be produced. We want the molten metal to enter without any turbulence. Otherwise, my dear, it would be resulting into some defect. We want molten metal to enter to the cavity in the minimum possible time. If the time taken would be more, it may solidify in between. And that once again, you would be having some kind of defective casting. We don't want any kind of dross formation. Jhaag nahi banna chahiye. So all these are the responsibility of a good gating system. So for that, we need a wide variety of elements in the gating system. I am making a rough figure of that gating system, what it looks like. Okay. So you can see this. This is how. Okay. Let me make it again. Okay. So you would be having like this. Like this. So here we will not be talking about cavity and riser. Cavity and riser we will see afterward. Right now we are talking about the gating system. So gating system is everything which is from this ladle. Molten metal is coming from the ladle. So from this ladle to this entry point, from this to this, everything covered under the gating system. Okay, is it clear? Ha, great. I mean, that's what I am saying. Because this is scientific study which says सुनने से जल्दी याद होता है rather than पढ़ने से. ठीक है? So that is scientific study. So my dear, this part is said to be the pouring basin. This part is said to be the pouring basin. And my dear, this is made such that molten metal should not directly enter from here. Otherwise, when molten metal would be coming from that much height, definitely there are chances of there are chances of the vortex motion, and also because of that much momentum, we may have some kind of dross formation also. So to avoid this, we are going to pour the molten metal here, and after the filling of pouring basin, molten metal will go slowly. And to reduce its momentum in the path, we are going to have one strainer. That strainer have two purposes. One purpose is to reduce the momentum of molten metal, and second purpose is if any foreign element is there inside, it would be absorbing that as well. Then my dear, this part is said to be the sprue, okay, and this part is said to be the strainer. So strainer is a kind of jali. आपने जाली देखी होगी, bathroom में भी होती है. So that kind of jali is strainer. So my dear, now the molten metal is coming here. Still it would be having some kind of momentum. So we are going to have splash core, which is once again made up of ceramic, and this splash core is provided to absorb the momentum of the molten metal, and this is once again going to store the molten metal at the bottom. So it is said to be sprue base well. Okay, it is said to be sprue base well. And my dear, once molten metal is entering here, we will allow the molten metal to go like this. Okay, and this thing is said to be the skim bomb, and that is provided once again for the impurity, for the smaller property. For the smaller impurities, it would be having heavy impurity inside and lighter impurity inside, and rest molten metal will be entering. And my dear, then once again you can see this is said to be the ingate, because this is the gate for the molten metal to enter into the cavity. So guys, this thing is something said to be the gating system. So you can see these all components from pouring basin, sprue, strainer, sprue base well, splash core, skim bomb, and this is said to be runner. All these are the parts, ingate are the part of gating system. So after that cavity will come. So right now when we are talking about this part, this is not arbitrarily made, this is particularly designed. And you can also ask a question, sir, why this is made up of taper? Why not you have made cylindrical? So that also comes by design. That's why I am saying we are not making it arbitrarily. It is properly designed. Otherwise, we will be having the defective casting. So this is one more diagram which you can feel. This is pouring basin. Here would be the strainer, sprue base well, choke. You first of all ignore it. We will see what is choke. Then runner, ingate, and casting. Okay, this is the diagram we have seen. Now, my dear, we have already seen the characteristics or objectives of the gating system. Now we will see the types of gating system. So there are generally four types. Very good, Utkarsh. There are four types of gating system: top gating system, bottom gating system, parting line gating system, and stepped gating system. So my dear, top, bottom, parting line, and stepped, from these two generally numericals are coming. So these two are important for the numerical point of view. Okay, and rest two would be coming for the application point of view majorly. Okay. So let us see first of all the top and bottom gating system. So this is a very rough diagram for a top gating system. Okay. Great, Shruti. So when we are talking about this, this is the rough diagram of a top gating system. But what is the definition of top gating system? If molten metal is entering from the top, you can see at the top of the cavity molten metal is coming. So we will call it as top gating system. Okay. So what are the advantages of this gating system? First of all, when molten metal is coming from the top, it would be feeling like this. It would be feeling like this. Let us say there is a time at which this much cavity is filled. Now you already know the first layer was this one. First layer was this one. So if the first layer is going to solidify, because it came first, it may solidify first. It is not going to affect the other upcoming molten metal. So I will say temperature gradients are favorable. Okay, because solidification happened from bottom to top. So it would not be affecting the molten metal to come inside the cavity. Temperature gradients are favorable. But as you know, it is coming from top. Definitely it is coming from top. The chances of dross formation are more. You must have seen to the street man, जो कि milk दे रहे होते हैं, they are going like this from the top to make the jhag, to make the dross. Okay, so here chances of dross are more, but temperature gradients are going to be favorable. But when we will calculate the time required, the time required to fill the cavity by top gating system is coming out to be lesser than that of bottom gating system. So that is why, that is the advantage of the top gating system. Less time means what? It would be not solidifying before filling of cavity. Then my dear, if we see the bottom gating system, this is the rough diagram for bottom gating system. So molten metal is entering from here. So my dear, you know, when it is entering from here, the first layer, let us say up to this molten metal is filled. So you already know this would be the first layer. And if it is solidified, rest part would remain unfilled. So my dear, that is why I will call that it is, I will call it as it is going to be non-favorable temperature gradient. So my dear, here temperature gradients are unfavorable. Time required to fill the cavity is also more. But advantage is there is no turbulence, so there is no dross formation will happen. So there are all pros and cons we have discussed. Okay. So now if we are going for the derivation of top gating system, you can see this is the height of pouring basin. This is the rough diagram to understand. This is the height of sprue. This is the cavity having area A and height H. So my dear, you know that when the molten metal would be coming here, it would be coming with a velocity, and that velocity is said to be velocity at in gate. It is coming out to be 2ghm. Hm is the height of molten metal, and Hm is given as H1 plus H2. So my dear, there is an area of ingoet, that is Ag. So if I want to find out the time required to fill the cavity, you know the volume of cavity is equals to the volume flow rate from the ingate into the time required to fill. So you would be getting time required to fill by the top gating system. It would be coming out to be A into H divided by Ag into 2gHm. Okay, so if out of H1 and H2 one term is missing, you can skip that. This is from where the second numerical will come. This is from where the second numerical will come. You have already seen that first numerical will be coming from permeability number. Second numerical would be coming from this. Okay. They can also ask you about the velocity by which it is entering. So for that I already told you 2gHm would be the formula for that. Okay. This is for the top gating system, guys. So my dear, the point is whenever we are going for this, like this was the diagram. This was the diagram. Okay, this is point number 1. This is point number 2. This is point number 3. So my dear, whenever we are going to apply the Bernoulli equation at point 2 and 3, so we are saying that this is point number 2, this is point number 3. Okay. So point number 3 is obviously open to the atmosphere. So at point number 3, pressure will be, okay, something is coming. Age is minimum area. Dear, I cannot say age is minimum area. That will be depending on the gating ratio. Okay. Take G in mm. Definitely that you need to take in the same units. This is not an empirical relation. Utkarsh, very good. Bilkul. But this is the revision session, so those kind of things I'm not telling you here. Okay, units and all, they will be helpful in the practice session, I feel so. Okay, so if you want, I can tell you that also. So I would be telling you when you are putting the Vg as 2gHm. So mind it, whenever you are putting the value of Hm, if everything you are putting in centimeters, if I is in centimeters, G should also be in centimeter. Okay. If that is in mm, G should also be in mm. So always take care of that unit, otherwise you will make the mistake. So my dear, now if I have applied the Bernoulli equation at point number 2 and point number 3, we are considering 3 to be datum. Okay. So 3 is open to the atmosphere. So if 3 is open to the atmosphere, gauge pressure at point 3 is going to be 0. And jet 3 is also going to be 0, because that is the datum point. So my dear, whenever you would be applying the continuity equation, A2 V2 will be coming A3 V3. We have considered the cylindrical sprue. If sprue is cylindrical, A2 A3 will be cancelled out. We are getting V2 to be equals to V3. then this and this will also be getting cancelled out. Then you would be getting P2 to be minus rho GH2, which means negative pressure. So it is saying that pressure at 2, gauge pressure is negative, means pressure at 2 absolute is less than the atmospheric pressure. So if at 2 pressure is less than atmospheric pressure, it will result into what? If pressure is less than atmospheric pressure, air from outside will enter into the cavity. Air from outside will enter here. That would be creating defective casting. So entering of air because of pressure at 2 to be less than atmospheric is said to be air aspiration effect. And my dear, we strictly need to avoid it. So if we want to avoid it, for that we need to keep the pressure at 2 to be minimum. Minimum pressure at 2 should be the atmospheric pressure. So if we are going to consider that, once again we will apply the Bernoulli equation, that P2 by rho g plus V2 square by 2g plus Z2 is equals to P3 by rho g plus V3 square by 2g plus Z3. You know Z3 is 0 because of datum. You are saying that to avoid, because we cannot afford entering of air inside. So to avoid that air inside, here it is not about, okay, you are talking Utkarsh about pressurized and non-pressurized. थोड़ा सा रुको, आगे मत दौड़ो ज़्यादा, ठीक है? So I am telling you this, that when we are talking about this air aspiration effect, this I am talking about the entry of air because of pressure getting lesser than the atmospheric pressure. So we have to avoid it simply. Then my dear, you know that Z3 is going to be 0. And if you are saying P3 is atmospheric pressure, P2 and P3 gauge pressure would be 0. Okay. So when they would be 0, now we are having this equation V2 square by 2g, V3 square by 2g. Now V2 cannot be equals to V3. If V2 will be equals to V3, then what do you understand by Z2? There is no meaning. So that is why V2 cannot be equals to V3. And if that is the case, by continuity equation, A2 cannot be equals to A3. It means area needs to be changed. Okay. So now we will find out that what kind of area change should be there. So then you will find out the area at 3 to the area at 2. It would be coming out to be the ratio of square root of H1 by Hm. Yes, Utkarsh, is it clear? Now tell me. Now tell me. Now tell me, is it clear whatever I have written? Or I shall do the derivation for that? This is the time to tell. Let us see how many of you remember. H1 by Hm or H2 by Hm? H1 by Hm or H2 by Hm? Yes. Now tell me. Amir, Utkarsh, Malaysh is saying, sir, H2 by Hm. So will it be H2 by Hm? Will it be H2 by Hm? Yes. Now what you need to do, you need to this apply the formula V2 square by 2g plus Z2 is equals to V3 square by 2g. You know V3 is nothing but root 2g Hm. I will be putting the value, this is square divided by 2g. You will be getting here as Hm. So you would be having V2 square is equals to 2g. This is going to be Hm minus Z2. Hm minus Z2 is H2. You would be getting 2g H1. Okay. So my dear, when you will find out the ratio, what you will be getting this ratio to be, you can see here that V2 is going out to be R times of V3. Okay. So then you would be getting this R is nothing but A3 by A2. Okay. And that ratio would be coming out to be R is equals to A3 by A2 is equals to square root of, it would be coming out to be H1 by Hm. So Malaysh, that would you will get. Okay, this is said to be the area ratio. So you need to keep this ratio of A3 and A2. So you can see area at 3 and 2 are not equal, but they are depending on square root. Means the variation of A2 to A3 will be parabolic. So if you would be making from here what we are getting, the area variation at 2 and 3 should be like this parabola. If this is A2, this is A3, this should be the variation. But for the simplicity, we will make it taper only, and that is why we have shown the screw to be taper. So that is the reason to avoid air aspiration effect. Like Utkarsh was saying, to keep this, we are going to make this kind of taper thing. Okay. Definitely. It is confusion, but now I feel it is clear to everyone. So moving to the time required for the bottom gating system. If you are having this bottom gating system, this is H1, this is H2. So guys, to avoid your confusion only, I am going to provide you the formula sheet. So tonight, after you can say around 12 p.m. or you can say 1 a.m. tonight, you would be getting the formula sheet of casting. Take the printout of that, okay? And whenever you are going for the exam or test now, before that just revise from that formula sheet. So I am providing you formula sheet for that purpose only. I mean that integration is not required here. So I am thinking to give you direct formula here. But in the question, when I will be coming with the question series, in the question, I will take one conventional question from parting line gating system. There I will derive it. Okay. Here I am not deriving because for gate it is not required. But in question I will take it for your request. Okay. So my dear, this is H1, this is H2. AG is the gate area. From here, molten metal would be entering with the velocity of Vg. And my dear, let us say at some instant up to H height we have filled, and the total height of the cavity is capital H. It may vary from this to this, whatever the height of cavity we are keeping. Capital H is the height of cavity. H1 plus H2 is the height of molten metal. Okay. So formula sheet of how subjects. Dear, first of all, let me start from today. All the sessions which I will take, for those subjects I will provide you. So I will provide you for SOM, for TOM, for MD, for production, okay, and if possible for IE also. For these much I will try to give you. Okay, so let's move further now without wasting the time. So guys, here are the formulas which we need to use. For the top gating system, we have already seen the formula. This is the formula for bottom gating system. Time required to fill the cavity by bottom gating system is 2 times of area divided by in-gate area root of 2g HM minus H. This H is the height of cavity. Okay, HM is the height of molten metal, you already know. In this case, V3 will be 2g HM minus H because molten metal is coming from a height of HM. And this H is a variable. So that is why here velocity will all the time changing from various values, because here this is fixed, here this is variable. So velocity will be variable. That is why this formula is coming for bottom gating system. But if we take a special case where height of molten metal and capital H becomes equal, for that case you will find the time required to fill the bottom gating system is 2 times the time required to fill the top gating system. So in the questions many times they have given this condition, then you can directly use this formula that bottom gating system would be taking 2 times than that of top gating system. Okay. If you want, I can provide you for other subjects also. There is no problem. Okay. If you want, I can provide you for other subjects also. For that, you have to just request on the Telegram channel of mine. I will share one by one. So I will try to provide one day one subject like that. Okay. So this we have already seen for top and bottom gating system. This is parting line gating system. So my dear, this parting line gating system is, thanks Abhishek. So let us start now the parting line gating system. This is the combination of top and bottom gating system. So my dear, if we have cavity in such a way that one part of the cavity is filled by molten metal coming from top and one part of the cavity is getting filled by the molten metal coming from the bottom, we will call it as parting line gating system. And if you want to find out the time required to fill this cavity by parting line gating system, you will be using the formula for top gating system for part A. You would be using the formula of bottom gating system for part B. So time required to fill the cavity will be time required to fill of A, time required to fill of B. A will be using top gating system, B would be using bottom gating system. Okay. So guys, as per the Amit's request, in the practice session of casting and welding, I will take a question where I will derive the bottom gating system formula. Okay. Thanks Chili, thanks Abhishek for your wonderful love and support. Without your love and support, nothing is possible, guys. Faculties are also because of students only. So let's move further, guys. So parting line gating system we have completed. Okay. So this is the question if you want to do. This is your homework question you can do. And the same question I would be taking in the practice session. And this question actually needs the derivation of bottom line gating system. That's why I said I would be deriving the formula of bottom gating system with this question in the practice session. Those who can try, please try this question at your home. Moving to the stepped gating system. And with this, the gating system would be over. Stepped gating system is used for very, very big size of casting like lathe bed. Lathe bed is a very big size. So if you are going to make that kind of casting, you would be requiring multiple gates so that you can give input of the molten metal from multiple points. So for that we are using the stepped gating system. So you can see A, B, C, all these are the gates we are providing, and this is used to make very big size of castings like lathe bed. So this is about the stepped gating system. So I feel we have completed all the types of gating system. Now we are talking about the choke area. So guys, this question was asked in GATE 2014, 2014. It was asked, what is choke area? So many students were having at that time that bad. They were thinking that inigate area is the choke area. Some people were thinking like screw area is the choke area. But my dear, choke area is the minimum cross-sectional area which is there in the gating system. In the gating system, we are normally talk about three areas. Like when we have this kind of gating system like this. Okay, after that cavity will come. So here three areas are very, very important. What are those three areas? One is this area of screw. Second is this area of runner. Third is this area of ingate. So out of these three areas, that area which is minimum, that would be said to be the choke area. So my dear, whether it is screw area, runner area or ingate area, its calculation are done by this formula. Here M is the mass of casting, rho is the density of the molten metal, TF is the time required to fill the cavity, CD is the coefficient of discharge, 2G HM is the ingate velocity. So by using this formula, you can calculate the choke area. So choke area can be screw area, can be runner area, can be ingate area. Out of these three, it is going to be one of them. Okay? Very good, Naveen. Very good, Tomato. Good afternoon. So it would be one of them. So my dear, if that is the case, we have already defined all these things. If that is the case, now we need something known as gating ratio. So area of screw to the area of runner to the area of ingate, that ratio is said to be the gating ratio. So my dear, if you already know the gating ratio, you can calculate the choke area. Now choke area would be one of these three. So if you get one of these three, with this ratio you can find out others. So my dear, this is how we can calculate all the dimensions of a gating system if questions are giving you the gating ratio and all the detail required to find out the choke area. So this is how the things can be done. Very good, Abhishek. So moving further, guys. So my dear, now we are going to have two types of gating system. One is said to be pressurized. One is said to be pressurized. Other is said to be unpressurized. So when we are talking about unpressurized gating system, For that, sprue area is the minimum one. When sprue area is the minimum one, we are going to say that to be unpressurized gating system. Very good for Amir. So AS is the sprue area that is going to be minimum for unpressurized gating system, and that is generally used for non-ferrous materials. Okay, generally used for non-ferrous materials. When we are talking about the pressurized gating system, air in-gate area is the minimum area, and in the pressurized gating system, my dear, sometimes we are also going to provide the inert gas environment. Here we are going to provide inert gas environment. So always the pressure of inert gas is present. That is one of the reasons we call it as pressurized gating system. And because of that, we can also go for the casting of aluminium, where aluminium is very reactive towards oxygen. So in that case, we can use that as well. So Amin, on your request, Pudina Yadav is also here. So I feel this is the time to good afternoon, Pudina. Okay. So guys, now we will see about the riser design. We have completed step number 3. Now we are reaching to step number 4. So step number 4 is nothing but the riser design. Okay. So my dear, riser design is also very, very important. So riser, whenever we are talking about, it also have a very important function to perform. Riser is going to provide the molten metal in first 2 stages of shrinkages. So you already have seen that if we have this cavity, now I would be showing you only riser majorly. So you already know, if I say this, okay, I will be making a better diagram that will give you a better picture. Okay. So let us see, the diagram is like this. You are having this diagram. Like this. So my dear, this is the cavity. So you know, whenever solidification will happen, shrinkage will be there. Then riser is going to provide the molten metal for first 2 stages of shrinkages. Riser have majorly 2 functions, my dear. Okay. Riser is having 2 functions basically from my dear. One function of riser is to provide the molten metal. During first 2 stages of shrinkages. Second function of riser is, by looking at the riser level, we can feel whether the casting is full or not. If my dear riser level is completely filled, it means casting is also completely filled. So if you want to see whether casting is filled or not, we need to see the level of riser. But my dear, when riser will be able to provide molten metal in first 2 stages of shrinkages, if it is going to solidify in the last, that's why it is mentioned as directional solidification. So we want solidification to happen in this direction. Solidification must happen in this direction. Then only riser would be solidified in the last. It means the part of casting near to the riser should solidify in the last. That is the meaning of directional solidification. So for riser design, there are various methods, my dear. The first method is the Keynes law. Second is Chivorinov law. Third is Keynes method, shape factor method, modulus method, and shrinkage volume method. So my dear, now let us see all the methods one by one. So when we are talking about the Keynes law, what Keynes have said? Keynes said that there is a term known as cooling characteristic. He said cooling characteristic. Cooling characteristic is directly proportional to surface area by volume. Obviously, if one surface area is more, so for same volume, the one which have more surface area would be having more cooling, faster cooling and less solidification time. So more surface area means more loosen of heat. So my dear, Keynes law says that cooling characteristic is directly proportional to surface area by volume. My dear, I would also define a term modulus. Modulus is defined as volume by surface area. Modulus is 1 by cooling characteristic. Modulus sometimes is given in the question also. So that is why you must be aware of this term. Modulus is volume by surface area. So my dear, the second which is most important is Chivorinov law. Numericals are coming from this Chivorinov law. And when we are talking about the Chivorinov law, it directly gives you the formula for solidification time. It says solidification time is directly proportional to volume bate surface area, it means modulus का square. So it gives the formula for solidification time to be K times volume bate surface area का square. Here K is said to be the solidification constant, and that K is found to be a function of freezing temperature, melting temperature, conductivity, etc., etc., etc. Okay, so there are many factors on which this solidification constant is going to depend. So for two similar conditions, for two similar material for which the casting is prepared, you can say the solidification constant remain the same. Okay, so this is the formula, and many questions are there on this K. It is mentioned on which factors it is depending. Now my dear, Keynes method is not important for gate. When we are talking about the Keynes method, okay, this is actually giving us a curve between y and x. The curve is coming out to be this, and this curve is said to be the Keynes method, Keynes curve. Okay, if you make this y and x, what is y and what is x? X is said to be the freezing ratio. X is said to be the freezing ratio, and freezing ratio is defined as the modulus of riser to the modulus of casting. Y is defined as the volume ratio, volume of riser to the volume of casting. So this curve is an experimental curve which is going to be made with the experiments, and this curve says this y and x relation. So here y and x relation, when we are talking about, this is let us say, if you are going to say for this curve we are going to have this point. For this point, this is the value of y, this is the value of x. So from some relation which would be given to you between y and x, if you are going to find out y and x, both the terms are having the dimension of riser. So as it is the method to find out the dimension of riser, so if you are using y and x, y is having volume of riser but a volume of casting. This is modulus of riser, modulus of casting. So as modulus of casting and volume of casting are known to us, because casting's dimension would be known to us, but riser dimension would not be known to us, because for that only we are doing the design. So the problem with this is, it would be not a normal analytical method. Here we need to use this curve and we need to apply some hit and trial to get the answer, and that is why this is not required for gate. You can leave this method. For ESE conventional also it have been asked only once till now. So it is not required for gate, just I am telling you, because our other method is improvement of that. What is the other method? Other method is shape factor method. So if we are going for shape factor method, what they have done, they have kept on y-axis the same volume ratio, volume of riser but a volume of casting. On x-axis they have replaced the freezing ratio from the shape factor. Now my dear, this shape factor does not depend on the riser size, it is depending on the casting size only. And this method is also known as Naval Research Laboratory method. Naval Research Laboratory method. This curve is coming similar to that of the Keynes curve. So this is the modification over the Keynes method. So Keynes method will not be coming in the exam, but this would definitely be coming in the exam. So if you see this, but I mean today Pav Bhaji is absent. Okay, Pav Bhaji came. Okay, Teju, welcome to this session. So I was waiting, where is Teju? Chaliye, let's continue. So guys, now when we are talking about the shape factor is defined based on the size of the casting. So my dear, when we are talking about the shape factor, if we have a plate, so okay, if we have a plate like this is the length L, B width and T thickness. Then shape factor is L plus B divided by T. This is the shape factor which would be coming from the size of casting. Okay. So my dear, if you have the size of casting, you can find out the shape factor. And you would be given a table. In this table, they will be saying that this is the volume ratio, this is the shape factor. So you would be having these values like this. So here would be some value, let us say shape factor is 2, 4, 6, 8, 10. Here would be some value 0 0.2, 0 0.4, 0 0.5, 0.7, like that. So I think once you would be finding out the shape factor value, then just from using this table, let us say this is the value of shape factor, you will get the ratio of volume of riser to the volume of casting. Now volume of riser you need to find out, and volume of casting you already know. So that is how you can find out the volume of riser. This method is said to be the shape factor method. So my dear, you just need to remember the formula of shape factor. This is for the plate. For the sphere, when you will calculate for the sphere, it is going to be d plus d by d. It means 2. For cylinder, it would be d plus h divided by d. So this is the shape factor of cylinder. This is the shape factor of sphere. You would be getting only these three shapes. So you can remember the shape factor formula. Okay. So this is how the shape factor method is going to be used. Now my dear, we are left with only one method. After shape factor method, we have modulus method. So modulus method is very easy. What modulus method says, that if you are designing a casting, keep the modulus of riser to be 1.2 times of modulus of casting. Means modulus of riser should be 20% more than the modulus of casting. Okay. So what is the meaning of that? You know, solidification time is directly proportional to modulus ka square. So if modulus is more, solidification time is going to be more. Hi Dhruv, welcome to this session. So I feel you guys got this method. So today you are getting all the formulas. Maybe on Tuesday we will have a practice session of welding plus casting. Okay. So I feel you got it. And now I am talking about the shrinkage volume method. Now the shrinkage volume method. So when we are talking about the shrinkage volume method, if you want to apply this method, for that, you know that you need to go for two conditions. One is said to be the necessary condition. Necessary condition. Other is said to be the sufficient condition. Sufficient condition. You need to apply two conditions. For that, first of all, you would be given that the volume of riser is 3 times to 4 times the volume of shrinkage. So that 3 or 4 what you need to take would be given in the question. If it is not given, you can consider 3 times. So first is the necessary condition. Sufficient condition, you need to check modulus of riser should be more than equals to modulus of casting. If let us say using this formula, you are getting the radius of the riser to be 7 centimeter. If putting this 7 centimeter, this condition is satisfied, then your answer would be 7 centimeters. But on applying this condition, if we get R to be equals to 9 centimeters, then my dear, the answer will be 9 centimeters. So my dear, answer will be maximum of these two. If this says 7, this says less, or 7 is satisfied, 7 will be the answer. If this says 7, this says 9, the answer would be 9. This is how you need to apply. Sir, I am in IIT Delhi Industrial Engineering. Should I aim for PSU or college? Dhruv, definitely you must aim for PSUs, because placements even at IITs are not up to that level that every student is placed. Definitely you must be placed if you are doing well, but still you can prepare very easily, because in MTech we have sufficient time. And the point is, when you have already cracked that exam, you don't require that much effort again. Okay. So moving further, guys, now we are moving to the last, the type of riser. The types of riser. Yes, guys, you know what are the two types of riser? The first type of riser is the top riser, and second type of riser is the side riser. So do you remember when we are using top riser and side riser, what are the relation of radius and height? Yes, Teju, Malesh. Yes, top riser is like this. Here I will not be showing the gating system. This is top riser. This is the side riser. So do you remember when you would be using this? This time volume of riser is going to be pi by 4 d square h. And if I am talking about the surface area of riser would be pi by 4 d square plus pi dh. But for this case, volume is the same, pi by 4 d square h. But surface area is 2 times pi by 4 d square plus pi dh. Okay? So when you would be minimizing the surface area, here you would be getting height is equals to radius. Yes, Amir, is it fine or not? If you want, we can go for the derivation, but this is not required at this level. When you are preparing for GATE, when you are revising for GATE, then we need not to go for the derivation, because in revision part, you require only formulas. These derivations are not at least required. Yes, Amir, is it fine or not? Please tell me. Then we are moving further. Yes, other students, Manas. Are you there or not? Okay, so this is, yes, Naveen, is it clear? So if anybody wants any derivation, you can tell me, but it is not required at this level, because when we are revising the things, then we just need to see the formulas. That is the meaning of revision only. If we go for formula derivation, it would be very lengthy. Okay, but if any derivation is important from which question comes, I will surely do that. Now we are moving to the next step, my dear. The next step after riser design is melt the metal. Melt the metal. So my dear, now we would be taking the metal and you would be taking metal to the furnace and it would be melting. And you would be getting the molten metal. 6 is the pouring of molten metal. So when you know the pouring the metal, I already told you, we would be pouring the metal at the pouring temperature, and this pouring temperature would be melting point temperature plus 100 to 150 degrees Celsius. This is said to be the degree of superheat. This is said to be the degree of superheat. Okay guys, this is said to be the degree of superheat. So this is how we need pouring temperature to be more than melting point temperature. The reason for that is to maintain the fluidity of molten metal. To maintain fluidity of molten metal. If molten metal is going to solidify, its fluidity will be affected. So my dear, you get to know fluidity is the property of molten metal. Now, like we have done the test for permeability, we have test for fluidity also. And the test which is done for the fluidity is said to be the spiral test. For that, we would be having such shape of spiral cavity. So we would be having this spiral cavity, and in this spiral cavity, we will be allowing the molten metal to enter. We will be allowing the molten metal to enter. We would be allowing the molten metal to enter. So molten metal at pouring temperature would be entering into this spiral cavity. And when it would be going inside, because of heat dissipation to the surrounding, its temperature will decreasing, and maybe after some length it gets solidified. And once it gets solidified, it will not move further. So my dear, the length covered by the molten metal before solidification is the indication of fluidity. So my dear, more the length covered by molten metal before solidification, more will be the fluidity of the molten metal. So this is how we are going to define this test for fluidity. Now, if this cavity would be having constant size, then we will call it as rod test. And if its diameter will be decreasing throughout, then we will call it as B test. So these are the tests performed to see the fluidity, to check the fluidity. Okay, so it is the ability of molten metal to flow and fill the cavity before solidification starts. So my dear, we have already talked about the test. Okay, now we are moving to the next step, which is solidification. Step number 7. I told you only up to riser design things are difficult. After that the things are very easy, and I feel within 30 or 40 more minutes we will complete it. So be there in the session. for my motivation also. It is not like important things are gone, so we will go. Okay. Otherwise, I will also not cover casting defects. So we will complete it. Just be there. It is a good revision for you. And if you like it, you can write in comment section. We will come for other topics as well. Okay. Sure. Very good. Very good. Very good. SP Shubham. So guys, when we are talking about solidification, solidification happens in two ways. One is said to be skin forming, other is said to be dendritic growth. Skin forming type of solidification happens in pure metals. Okay, pure metals or the materials having eutectic composition. Materials having eutectic composition. Now, eutectic composition, everybody would be understanding, those who have studied the material science. Okay. Definitely, बिल्कुल मानस नॉन कन्वेंशन से तो थ्योरी क्वेश्चन आएगा ही आएगा. So we have to do that. So in skin forming, what is going to happen? I told you, you take an example. If you have a bowl and you are keeping the water into this and it is get into refrigerator and you are solidifying it, then you must have seen if electricity gone. If electricity gone, then my dear, what happened? Then if you see the bowl, you will find in between water is there, but from side solidification has been happened. So my dear, similarly, this is the top view of the molding wall. So molding walls are cooled, molten metal is hot. So solidification front would be starting from the molding walls like that. So when solidification front would be starting from there, okay, they would be starting and going from all the molding walls like that. So when it would be going like that, and you know solidification will also happen. So because of that, you would be having a cavity at the center. So here you can provide the riser and fulfill this cavity from the riser. So this type of solidification is said to be skin forming. It is the perfect one. Here no defects are coming because of the riser positioning. Second is dendritic growth. So my dear, you know this randomly growing solidification front is also said to be the dendrite. So from sideways, always the dendrites are moving. But if, my dear, this molten metal is having a mushy zone means where some solid and liquid take place, where the composition is not eutectic, where you don't have the pure metal. There you may have some other pieces of metal present in between. Because of that, some second dendrite solidification fronts are coming from the center. Whereas these primary and secondary dendrites are going to collide, you would be having a cavity there. Those cavities are said to be shrinkage cavities. Because of shrinkage, it is going to happen. And if they are coming more than in one number, we cannot provide that much number of risers. That is why for such cases, we would be having some kind of defects. So for that purpose, my dear, we are going to provide the chills. So we would be providing some metallic pieces chills, which would be not providing the secondary dendrites to form. They will make the primary dendrite to form at center faster, because when you would be providing a chill here, primary dendrite would be coming from here also, and before secondary will start form, they will cover the entire structure. So my dear, by providing these metallic pieces in between, you can stop the formation of secondary dendrites. Kenil sir, will you cover metal forming? Dear, I want to cover every topic, but for that you need to present in the sessions. Because if you would be coming, then only I will be coming to cover that. So your interest should be there. Like in casting, you have responded. I would be having welding. If the same response, we will go for metal forming. Same response, we will go for cutting. So it depends on your response. If your interest will reduce, then my session will reduce. If your interest will increase, my session will increase. It totally depends on you. Okay. If you are ready, we are always ready to give you. Sure. Okay, let's move further. So we have seen the skin forming and we have seen the dendritic growth. So everybody understood the function of chills? Please tell me. Everybody understood the function of chills? Please tell me. Chills, fine. Next we are moving for the fatally. My dear, now you have already solidified the product. Everything is fine. Now my dear, we are going to break the mold. So we are going to break the mold. For that, sometime to breaking the mold, we are using the vibration mechanism. So because of that vibration, the mold would be broken, because now we need our product to come out from that mold. So for that, mold should be broken, and that process is said to be fettering. Next is one part of this is sandblasting. Like whenever you are breaking the mold, still some sand particles are there on the surface of the casting. So let us say you have a cylindrical casting and on this some sand particles are still there. So for that what we are going to do, we are going to take some steel balls of 2 to 5 mm. We are putting those steel balls onto the surface of casting at some high velocity, and because of that those sand particles are getting removed. This process is said to be the sand blasting. Then my dear, surface finish is done of the casting product. For that we are going for machining. It is the same machining for which we have given the machining allowances. Okay, that is what we are going to provide. Then after that we would be having the 10th step, that is the inspection or testing. So to test the already made casting product, we have various ways. The first way is the coiling technique. This is, you can say, not a very scientific technical method. You would be having a coin of 2 rupees, 5 rupees. You would be knocking onto the casting. If it sounds same throughout, it means casting is good. If it sounds different at different parts, it means some defects are there. Okay. Second is, you can pass ultrasonic and X-rays. If pattern comes same throughout, your product is fine. If patterns are coming differently at different location, it means some defects like porosity and blowholes may be there. So this is how the complete work is done. Now we are going for the core design. Okay. Within 5 minutes, we are going to enter non-conventional casting, and by 1:15 or 1:20, I will complete it. So I asked you to complete casting in 2.5 hours. I am going to complete it before 10 minutes. Okay. So we are going for core and core design. You already know cores are used for the hollow casting. So let us say you want this kind of circular hole in this casting. So for that this core is placed there. The seat of core is said to be the core print. So if this is core, this is said to be the core print. Okay. Now my dear, you know the weight of core would be acting downward and buoyancy force would be acting upward. If I would be asking you the weight of the core, it is going to be m into g. It is density of core, volume of core into g. And buoyancy force would be coming out to be density of molten metal, volume of core into g. Because this is the weight of the volume displaced. So volume displaced will be equal to the core volume. But weight means density would be of molten metal. So my dear, buoyancy force is acting upward, mg is acting downward, and everybody understand molten metals density would be more. So when you would be finding out the net force, it would be coming out to be rho m minus rho core into volume of core into g. So the net force will be coming out to be density of molten metal minus density of core into volume of core into g. That force is acting upward. It will try to break the core. For the stability of core, we are sometimes putting the metallic pieces. Okay, these metallic pieces are going to support the core from the net force which is coming, and these are said to be chaplets. Okay, so these chaplets are going to support the core under the action of these you can say buoyancy forces. Amir, yes, definitely we will do that, because in SOAP also, so don't worry, for that we have already planned accordingly. Okay, so don't worry, we have planned accordingly for that. So we would be completing this session by 1:15. Okay, then we will be moving further. Okay guys, so just wait. Okay, so guys, this is the core and its design. We have completing, and one more thing I would like to tell you about the paddings. Like if we have this as the casting product, at the corners we will be providing. Okay guys, just wait. Yes guys, fine. So guys, this is said to be the paddings. So we are going to provide the padding. Sorry guys for the inconvenience. When we are talking about the paddings, These paddings are provided at the corners because at corners the casting is having generally weaknesses. So to avoid that kind of thing, we are providing the paddings because of you can say non-uniform coolings happen there. So to avoid those things, we are providing to support the corners. Midun, actually to find the area of chaplet, that is requiring some data books. Okay, so that kind of question will not be there in GATE because data books parts are not given, but there are some empirical relation in the formula note that would be there. You can remember it if you want. It would be totally your choice. Okay, so guys, moving to the non-conventional casting now, the last part of the chapter. So my dear, in the non-conventional casting, we need to remember the process and the application. Questions would be there from the application. So the very first type of non-conventional process is shell molding. So as the name suggests, here the name is said shell molding. We are going to make shell actually. So my dear, in this what we are going to do? We would be having a cast iron or some metallic pattern. So this cast iron pattern would be having a shape related to the shape we are looking for. Okay. Okay, Abid. So my dear, we are going to have this cast iron pattern. First of all, we would be heating it to a temperature of 200 to 250 degrees Celsius. So when we would be heating this cast iron pattern from 200 to 250 degrees Celsius, after heating this pattern, my dear, you would be placing this pattern onto a container with the proper clamping arrangement, which is having some sand mixtures, silica sand, phenolic resin and alcohol. Alcohol is provided for localized heating, silica sand you know, and my dear phenolic resin is for the proper bonding. So my dear, now we will be inverting this box. When you will be inverting this box, you would be getting some layer of this mixture onto it. More the time you will be providing, more the layers would be made. After that, once again, you would be taking this pattern out, and on this pattern, you would be having some thickness based on the time of contact of this pattern with the sand, and you would be having some desired thickness of this shell like this. Now we can take this shell away, and after taking this shell away, we would be keeping that into oven to increase its strength. And such 2 to 3 shell then would be joined to make the cavity. And in the cavity you will put the molten metal and the final product would be made. In the oven it is heated to 300 to 350 degrees Celsius. Pattern are heated from 200 to 250 degrees Celsius. So this process is said to be shell molding. Okay, this is the first type of non-conventional process. This is used to make for the symmetrical circular shapes, to make the IC engine cylinder heads. So IC engine cylinder heads are made by this. So you may be asking me, sir, what we need to remember here? You need to remember this application, that IC engine cylinder heads are made by shell molding process. They can ask you the purpose of adding alcohol. You will say the localized heating. Okay, I feel so you are getting it. The second type of process is nothing but the slush casting. So my dear, slush casting is used for some kind of ornaments. Okay, some kind of ornaments. It is used for the statues. Okay, it is used for the toys. You might have seen the serials like Surya Putra Karn, like Mahabharat, like Ramayana. Okay. Okay, you have seen that. So Ramayana, Mahabharata, Surya Putra Karna, such kind of serials you have seen. The kings were wearing very heavy ornaments on their bodies, very heavy jewelry on their bodies. Okay, so my dear, when you would be having those jewelries, how they are going to manufacture, I am telling you. This is how the slush casting is done. So you would be having a cavity like this. Let us say you want to make a kundal of Surya Putra Karna. That was the shape of kundal. So you want to make a kundal, you would be making a cavity of this size. Okay. Now this would be having the cavity. Okay. This is the cavity. Now you would be pouring the gold into that. Gold will be poured. At that time, gold was not having that much value. And when the gold is going to be poured, you know that solidification will be starting from the wall. Once you will get the desired solidification thickness, you would be inverting it back, rest gold would be flowing, and you would be getting your product like this. This is the kundal of Suryaputra god, and my dear, this is how the ornaments are made. Likewise, hollow statues can be made. Hollow statues of various, you can say, the peoples from the past, like you must have seen the statues of different political members and all. Okay, so all these things are made by slush casting. Now, my dear, as you are not going to allow the complete solidification, this process is also famous with the name of partial solidification. And my dear, that partial solidification, for that we need to find out the time. So if you see that time required for solidification, this is K times volume bate surface area ka square. For thin geometries, volume bate surface area is given as the thickness. Okay, so this is given as the thickness. So my dear, solidification time is directly proportional to thickness ka square. So you can say solidification time, when we are going to say, this is directly proportional to thickness ka square. So thickness is directly proportional to solidification time ka square root. Okay. So my dear, you can write the equation that thickness is equals to C1 times of solidification times plus C2. So this is the relation between thickness and solidification time. From this there is no light shade are also made by that. Till now there is no question from this, but I am damn sure you would be getting a question surely this year or next year from this topic, and there they would be asking you for 10 mm of thickness. Okay, the solidification time is, let us say, 5 seconds. For 8 mm of thickness it is 4 seconds. Then for 15 mm of thickness, what would be the solidification time? Using these two data, you would be finding out the value of C1 and C2. Then putting this value, you will be finding out the solidification time. So this type of numerical you can have in the practice session. I will take this numerical. So guys, this is how the things are going to be done. Slush casting is completed. Now we are going for the investment casting. So you already know investment casting is very important, and this investment casting is also known as lowest wax technique. Okay, here what we are going to do. First of all, we are going to make a pattern of wax using the sand molding technique. So with that, actually it is not made by sand molding technique. Actually it is made by centrifuging casting, which we are going to discuss after this. So generally this type of patterns are made by centrifuging casting. Centrifuging is again non-conventional. I already told you that if a conventional casting follows the 10-step procedure, if any of those 10 steps is missed up, then we will call it as non-conventional. You can see in slush casting, in the shell molding, we are not using those 10 steps which we are doing in the conventional casting. Okay? Yes, very good, Amin. So you would be having this kind of wax pattern by centrifuging casting. Then this type of multiple patterns you would be making to attach with this shape, which is said to be the pattern tree. Because it is in the shape of tree, you have applied these wax pattern onto the walls of this tree. So this tree is given the name of pattern tree. Now my dear, we would be taking this pattern tree and we would be putting this pattern tree into this slurry, which is having silica plus ethyl silicate plus water. So you would be having multiple dips of that pattern tree, which would be making a layer of the slurry, onto the pattern tree like this. Okay. Now my dear, this slurry is a jelly kind of thing whose melting point temperature is quite more than that of wax. Now you will heat it. After heating, all the wax is warm, that is going to melt out, and after that you would be pouring the molten metal into these cavity, and after that you will separate them and you will get the products. So my dear, all the medical instruments which require more surface finish, like turbine kind of things which require more surface finish, we are going to make them using this investment casting. Here you can remember this slurry which is having silica sand, ethyl alcohol and water. Okay, so this you need to remember. And second thing, you can remember this application. The major application is gas turbine blades, jet engine parts and surgical parts or medical instrument. Will the material will be only wax or only, dear, generally wax is there, sometimes mercury is also used, but majorly wax is there. That is why the name is also lost wax technique, because at the end we are losing the wax. Okay, so guys, next we would be moving to the next technique, that is full molding technique. As the name suggests, this time we are going to make not only pattern but the full mold with the gating system with the riser. So you would be having some material like thermocol. For the thermocol material, you would be making this type of pattern, which would not only be having the cavity part but also the gating system, riser and the cavity. You would be making this of either thermocol or some kind of plastic or some kind of polymer or some kind of, you can say, such material which is having low vaporization temperature. So you have made it for, okay, I am saying some polymer, okay, or as I already said, for thermocol. You would be making it. You would be keeping this and you would be making the cavity of it like you have kept this pattern like this. And after this you are making the cavity. For that you would be putting the stand inside. Now all around we have the stand. All around we have the stand. Okay. Then my dear, now you would be putting the molten metal into this. As this is not empty space, this was the thermocol. It may be plaster of Paris also. Okay, it may be plaster of Paris also. So when you would be pouring the molten metal into this, it will not only melt but vaporize, because its vaporization temperature is very, very less. So it would be converting into gas and vaporizes. And when it would be vaporizes, it will become the cavity automatically and molten metal will be filling it and make the casting. So my dear, this type of you can say casting process or molding technique is used for making the tool cases or motor casings. They are very difficult shape to produce. So that is why we are using such kind of things to provide the kind of gating system and riser in between the pattern only. So the application for this are majorly motor casing and tool casing. That is what you need to use. If you are using thermocol, it's fine. If you are using plaster of Paris, it is also said to be plaster molding. So the name also changed with that. Okay. So next process is the centrifugal casting, the most important one. Last to last year, I told that numerical will be coming on this. You can see a Super 20 series of last to last year. There I have said this type of question was not there on YouTube before. You will see it, that was there in the exam exactly. Only the data was changed. So centrifugal casting, when we are talking about, for that you would be having a cylindrical cavity in two parts. Like this is a cylindrical cavity in two parts. We can add or join them with the clamps. So we are going to have a cylindrical cavity. Okay, and why I am saying in two parts? It means it is in split bush type. One is this, other half is this. They are joined with the clampings like that. So we have this cylindrical cavity. Okay, this cylindrical cavity is kept at a very less angle. This angle may be 2 to 3 degree, very less angle. Okay, and we would be starting this rotating at a very high speed, 8000 rpm, 9000 rpm. Sir, if I know some basics and follow marathon session of all subjects, dear, if you have idea, then definitely I can say more than 50 you can achieve. But for that, as you are saying, you know some basics plus PYQs are required. If you are going for the classes plus PYQ, you can easily score 50 marks. Okay, but for that, it should not be mugging up. It should be understanding of the things. Okay, very good, Jabir. So I feel you joined right now, Jabir. Huh? So when you are going to rotate it with a very high speed, now my dear, you would start the entry of molten metal from here. So when molten metal would be coming, because of this high speed of rotation, molten metal would be taking the shape all around the periphery. Because of centrifugal force, it would be going away from the center. And my dear, when it would be going throughout, obviously the thickness would be increasing. Once you will get the desired thickness, as you are going to make the hollow pipes, you are making the jointless pipe, seamless pipe. You are making the pipes with some thickness and they are seamless. They don't have any joint. So my dear, when you get the desired thickness, you will stop the flow of molten metal. During the rotation, only solidification will also happen. Heavier impurity will go outside, lighter impurity will come inside. So with the machining, you can remove the impurity after the casting process is over. And once the solidification over, you will stop the rotation. You will take the product out and you will close the cavity. This is said to be true centrifugal force because you have given very less angle. You are not using any gravity force to fill up it completely. That is why it is said to be true centrifugal casting. So my dear, in centrifugal casting, you know there is a force, centrifugal force mr omega square. Ma is mr omega square. Mm will get cancelled out. So acceleration will be r omega square. So my dear, this question was already there in the exam 2 years back. In the practice session, I will be taking numericals on all these things. So don't miss the numerical session of this also. So the application of this is making the hollow cylindrical pipes, large size bush and propeller shaft. This is the application of true centrifugal casting. Then we have semi-centrifugal casting. In the semi-centrifugal casting, molten metal will be coming inside with the help of gravity force. Then also it is rotating, so molten metal is going away at the periphery with the centrifugal force. So this type of casting is said to be semi-centrifugal casting. It is used to make the pulleys or the flywheel or wheels with the spokes. This is semi-centrifugal because using the gravity force also. Okay. I already answered this, Javed, because it is using the gravity force also. Now, my dear, we have already seen the application. Now, I am talking about the centrifuging technique. If you see the centrifuging, this is the top view. Molten metal is coming from the top with the gravity force. After that, it is going inside the cavities with the centrifugal force as it is rotating. And these are the small product, large in number. Like we were making the pattern of wax, or you can say wax pattern of investment casting. So such small pattern you are placing at all the peripheries, and with the rotation molten metal will fill it. After solidification you will separate your product, and this type of casting is said to be the centrifuging. With this you are going to make the pattern of investment casting. Okay, and here you can also make more number of small products, or some symmetrical or unsymmetrical products can be made. Seamless tube centrif, हाँ बिल्कुल आमी. Seamless pipes are made by true centrifugal casting. That I already told. I feel you missed that point. अभी शायद थक गए होंगे ना, 2 घंटे हो गए. That is why. So now we are talking about the die casting. When we are talking about the die casting, my dear, actually there are 2 types of pipes. One is seamless pipe. Okay, seamless pipe means jointless pipe. So they are made by centrifugal casting, and other pipes which have joint, they are made by the welding process, high frequency resistance welding. Okay, fine. Jabir, he is not talking about that. Wait for it. Okay, he is not talking about that. So I am here to. Okay, you are asking something. Bottle tube. Yes, that is something different. That is, you are talking about the kind of tubes which are like this, collapsible tubes. They are made by impact extrusion. Okay, that is the part of metal forming. We will see that again later on. So die casting will be having some permanent molds. Here the molds are not breakable, they are permanent, made up of metals. It is of two types, gravity and pressure die casting. In the gravity die casting, you can make the simple shapes. We are getting the help of gravity force only to fill the cavity. Aluminium piston is the product made by this. Pressure die casting would be used for the complex shape like carburetor, because it uses some pressure forces, external forces to fill the cavity, so any shape can be filled up. So that is why it is done in two ways. One is hot chamber, other is cold chamber. Let us see what is that. For the gravity die casting, you are going to make aluminium piston kind of thing. Like these are two parts of die. This die is the fixed die. This die is the movable die. Okay. You would be pouring the molten metal inside. Okay. After solidification, this movable die would be taken away. Otherwise, you cannot take the product out. And then there is some ejector rod. That ejector rod would be pushing the product, and you would be getting the product out, which is of this shape. Okay, so simple shapes can be made by this. And to fill it, you are using the gravity force. So that is the reason we are calling it as gravity die casting. Then we are having pressure die casting. Here you have this as cavity, and this is the molten metal. Here molten metal is getting filled up with the external pressure provided by the rod. Okay, here the molten metal is poured. This is said to be cold chamber because metal is getting melted somewhere. Metal is melting somewhere in the furnace. And from that, metal is coming with the help of ladle. So furnace is different, cavity is different. It is said to be cold chamber. So molten metal is poured. And my dear, whatever shape you want, you can produce from this because external pressure is used to fill the cavity. Otherwise, maybe due to gravity, sometimes the casting remains unfilled. Like if we have this type of shapes, then casting may remain unfilled. So to avoid that kind of thing, we are using the external pressure for that. Okay. So my dear, cold chamber casting is used for high melting point cases. Okay. So because whenever we are using this hot chamber, in hot chamber furnace is the part of cavity. In hot chamber furnace is the part of cavity. So it is used for the low melting point temperatures. Otherwise, this entire setup have to be of very good material which can withstand very high temperature. So keeping that into mind, for low melting point temperature we are using hot chamber. For high melting point temperature we are using cold chamber. Cold chamber means furnace and cavity are one thing only. Okay, they are not separate. And we have already seen with the pressure die casting, we are going to make the product like carburetors, which are having complex shapes. Okay. And my dear, in the cold chamber, there are chances of contamination because throughout when molten metal is coming, it is in contact with the air. But in a hot chamber, we will get high quality product as there are no chances of contamination. Is it clear? Thanks, Amir. ये compliment था या पूछ रहे थे? Okay. So we have seen this hot and cold chamber. Now the last type we are talking about. These are the application of pressure die casting. Last is continuous casting. Okay, continuous casting is this is a bowl which is said to be tun dish. This bowl is said to be tun dish, and we have this as molten metal. Molten metal is going like this. Okay, and when molten metal is coming like this, these are the dies. Okay, and with the die, when the molten metal is coming, obviously it will get solidified. And my dear, we would be having a shape with the help of die. And with that shape, this product would be coming out. We would also be having a spray of water for better cooling purpose. And then rollers are provided to maintain the shape, whatever shape it is coming with. So tun dish is a bowl with a hole, with a small hole. So this is a simple process of making the propeller shaft. Of shaft, we are going to use it. To make the shaft, we are going to use it. Okay. So this is said to be the continuous casting process. Okay, guys. So with this, we have completed the entire casting. Now, there are two things. One is the casting defect. One is the casting defect. That I will be going with the welding defect. Okay. So as welding is the small chapter, welding will be completed in 1.5 hours. So that is why to make it 2 hours, we would be having both the defects with the welding topic. And if you really want all the topic from my side, then definitely I want a kind of yes from your side. Otherwise, it should not be that I am keeping the session and you are not present. Because I am not doing for my revision, I am doing it for your revision. So please tell me, all of you, whoever present in the class, do you really want the same session for all the topics? Ha, bilkul Amir, we are going for everything. Very good Shashank, Amir, Manas, Nikhil, very good. Shreyas, very good. Shruth, बहुत बढ़िया. Okay. Thanks, Piresh. Midhun, very good. Sujesh, very good. Malesh, very good. बहुत ही बढ़िया. So guys, as tomorrow is festival, I was trying to have welding session tomorrow, but from the team it was like that 25th for festival. I let the students enjoy. So we are keeping welding on 26th of December. Okay. So we will be having the welding session on 26th of December. So I am keeping one session in the night, and then metal forming would be done on the daytime. Okay. So we would be going like that. Sure, Amin. Sure. Arjun, very good. So guys, with this we have completed the casting today, and tomorrow casting defect, welding defect plus riser positioning. As today I don't have the diagram of riser positioning. So with the diagram I would be telling you that also. Okay. So these three things we will see with the welding now. So we would be meeting once again on the Monday for the welding part. So hope everybody would be there and we will enjoy the session. So goodbye for today. Teju practice session would be after welding. On Tuesday we will keep the practice session. Then we will go for metal forming and sheet metal operation. Then that practice session. Then metal cutting and metallurgy and sim. Then that practice session. Okay, so goodbye guys for this session. Thanks for joining. Thanks for your love and support. Before leaving the session, do like it, share it with your friends. And definitely I feel you enjoyed the session. So we would be meeting once again for the welding on Monday. Yes, tonight at 10:45. At 10:45 today, we are going to have practice of Tom. Okay, on YT. So tomorrow on YouTube we have the mock test as well. Okay, so tomorrow we have mock test at 11 AM. So join that as well. So goodbye guys for this session. Thanks for joining. Yes, Naveen, I will definitely answer you. Join my Telegram channel, Mechanical by Dheeraj Sardana, so that you can get the PDF of this session and much more. Goodbye once again. Tonight you will get the formula sheet of that also. Goodbye.